Equations, intercepts. We've been talking about intercepts already. What's another word for an intercept? Yeah. Okay. Last year it was like that, right? It's got an x-intercept, got a y-intercept. Okay, this year, Shoni, it's like that. Still have x-intercepts, still have a y-intercept, but because it's curved, now you can have more than one x-intercept. The other word for that is a root. The other word for that is, what's it say in your calculator? A zero. Same thing, okay? Y-intercept, same deal. Equations, well, the equations are in that form. What form is that? It's either general or standard. Which one? Standard. Okay? General form looks like that. Okay? We call this vertex form in other books. I call it vertex form because it tells us the vertex. Okay? That's your P and your Q. That's the coordinates of the vertex. So, if you like flow charts, there it is. How are we going to determine the equation if we give you the vertex and a point? In a word, substitute. Substitutions. First, where's the vertex? Well, that's P and Q. Okay, put it in the equation. Then you're going to need a coordinate point, a one other than the vertex. You can't use the same point. You're going to plug that in. You're going to solve for A. Then you're going to replace A, P, and Q in this equation, and then you'll know that exact equation of that parabola. Okay? Because the vertex alone, like I could have, let's talk about roots. I could have lots of parabolas that have the same roots. Okay? Those all are parabolas. They all have the same roots. Okay, let's do a real fat one. But there's only one specific quadratic that looks like that. That's what A does. Tells you the exact shape of it. Okay? And it could be moved all over the place. That's what P and Q do. All right? So same thing here. A tells you the shape. You got to know what A is. Okay? I could have lots of quadratics that have vertex, I don't know, 2, 3. Okay? That one has a vertex 2, 3. So does this one. Okay? So does that one. But only one particular parabola has a specific value of A that makes that shape. Okay? It's not good enough just to have the roots or just to have the vertex. We want to know the exact equation of a particular quadratic. So, there's a vertex. Do you know where that is? Negative 2, 8? Negative 2 and 8, right there. That's the vertex. Do you know if this thing opens up or opens down? No, you don't have a clue what shape it looks. I know that's a vertex. We got to find out. So the first thing you do, well, if you got the vertex, substitute that in. That is PQ. That's the coordinates of the vertex. That is PQ. Remember, this thing does like an opposite sign, right? If you substitute it in here, you have y is ax minus, what's p? Minus 2. Put it right there for p. Okay? So it says minus minus. Squared, well, let's put everything else in poiple. All right, plus, what's q? Q is 8. There's step 1. Substituted p and q. Now, x and y. I have one equation. I have 3 variables. I can't solve that. I need 3 equations if I have 3 variables. You're lucky we don't do that in Math 11 anymore. Okay? But if I knew what x and y was, I could solve this for A. Right? Do I know what x and y is? Yes, I do. They're giving us another point on this graph. I know this graph goes through minus 1, that should say minus, and 7, right there. Do you think you know the shape of this quadratic with just those 2 points? Does it open up or open down? It opens down. That's the vertex. I know if it goes to that point, it's got to look like this, right? Okay, but anyway, we don't care about that. We want to solve for a. Y is 7. Substitute it in. 7 is a, what's x? -1. Substitute it in. Minus 2, well, let's make that plus 2. Don't forget the squared. Plus 8. Can I solve that thing for a? Should be able to. It's the only variable in here. Okay, so 7 is a, what is -1 plus 2? 1. 1 squared is 1 plus 8. Now what? Get rid of the 8. Minus 8 both sides. 7 minus 8 is -1, is a times 1 is just a, and I'm done. That's what a is. So, and by the way, we're doing this exact same stuff in foundations class, okay? They're doing just fine. It doesn't say, but they're having a problem with this. They want to go, yeah, I got a, woohoo! On to the next question. Did I answer this question? Find the equation in this form. Okay, I didn't do that. I know what a is. I got to go y is -1. I don't have to put the 1 there. X, what's p? -2, so I want to go plus 2 squared plus 8. That's the specific equation. Okay, only one equation, one parabola, one quadratic's going to look like that one. That's it. Yeah. Yes. Well, this is for every x and y point. Okay, let's say it looks like this. I don't know where the zeros are. Okay, this could be wrong. I'm just guessing. Every x and y point has coordinates. That satisfies this equation. If I told you x was 4, could we find out y? If x is 4 here, yeah, I could find out that point on this graph. Here it is. I could find out the y coordinate from this graph. Okay? Every point on there, that's what this means. That's the equation for it. So yeah, I want x and y in there. You remember last year? Y is mx plus b. There's 4 variables there. Write the equation in y equals mx plus b form, or slope y-intercept form, and maybe the equation looked like this. Okay? But you always had an x and y in there, and every point on that line was satisfied by this equation. The y-intercept was 4. I know it went through that point. I know the slope was -1/2, right? So it tilted up this way. 1 unit of rise, 2 units of run. That's what it looked like. Okay? So same kind of thing. Only now this is a quadratic, not a line. Okay? Rewrite this in general form. Okay, a little bit of working. This is what I got. I want to write it like that. Okay? So I want to expand this thing out. Y is negative. This is x plus 2 squared. What should be your first step? That. Remember how some of us missed some marks on that test because we didn't do that? We thought it was x squared plus 4. Yeah, don't. Just rewrite that. That's that thing squared. Write it twice. Okay? Plus 8. Now this minus, does that apply to everything in the brackets? Yes. Just save it till later. You could, and I did this in grade 10, I told you there's 2 ways to do that. You want to take this minus and multiply it just in that one, that's fine. But my recommendation is FOIL that first, then apply the minus to everything in those brackets. Okay, if you want to do it the first way, that's fine. Okay, so I got minus, what is this? X squared plus 2x plus 2x plus 4, okay, plus 8. So now apply that to everything, not just the first guy. minus x squared minus 4x minus 4 plus 8. I'm being lazy. That's what y is. And I could probably do one more thing. What's that? Yeah, collect like terms. Minus 4 plus 8, that's plus 4. So y is, in this form, minus x squared, okay, ax squared plus bx plus c. That's general form. Okay? And just like in, Math 10, this doesn't help us. Does this tell us a vertex? No. Does it tell us slope at that instantaneous point on a quadratic? No. It doesn't make any sense, right? Because it's always changing. Does it tell us anything? No. It's just in this funky form that some people deem to be important. Okay? So it's not as helpful as this. This we can graph it. This we can't. Unless you got a graphing calculator. Okay? Okay, speaking of which, use a graphing calculator to sketch the graph and determine the x and y intercepts. So if you got one, great. And if you don't, well, that's not a question I can put on the test, is it? Unless this is factorable, which it might be. All right? So minus x squared minus 4x plus 4 graph. Okay, did we expect it to open down? Sure, because it's a negative, right? And second function, trace 0. Well, that's over here, so let's do that one first. It's left of it, enter. Go right of it, enter, enter. It's 0.82, read the question, to the hundredths, 0.83. Okay, the other one, I'll go way over to that one. By the way, you don't have to tap yours, you can just hold down the button. I have to do it on mine because it's not a real calculator. But I saw a kid just today in Foundations doing that, and I was like, whoa, like, just hold it down. Oh, you can do that? Yeah, you can do that. Guess. Minus 4.83 to the hundredths, right? Okay, do we have a picture of this guy? Sure. Hey, that was pretty close. Look at that. That looks like about minus 4.83, doesn't it? That one's a bit big. It looks like about 1.1. Should have gone right there. 0.83. Okay, not bad for a rough sketch. Let's get rid of the line now. Okay. Those are the two zeros. That's where it crosses the x-axis. All right, finding intercepts from standard form. Algebra, that's what we're doing. Determine as exact values. What do you think now when you see that word exact value? Radicals. No decimals, right? No calculator, radicals. X and Y intercepts of this graph. Okay. In grade 10, I told you 17 times, this thing has two intercepts. It's got a y-intercept and an x-intercept. What happens as far as x is concerned on the y-intercept? Always, always, always. I don't care where that line goes. At the y-intercept, where it crosses the y-axis, x is always, always 0. What happens at the x-intercept as far as y goes? Y is 0. Always, always, always. Let's do the same line. Okay? Well, same thing. I don't care if it's curved. Don't draw that. Right? At the x-intercept, y is 0. At the y-intercept, x is 0. That's what we do to solve this thing. Okay? So let's do the hard one first. Do you remember which one was harder and easier last year? Solving for a line, which was easier, x-intercept or y-intercept?
Y was easier.
Yeah, y was the the easier one. You remember that. It doesn't matter. We've got to do both. Okay, x-intercept. What happens at the x-intercept? Y is 0. That's the concept. If you don't know that, it's going to be kind of tough. Okay, so let this be 0. Right? I'm finding a root. I'm finding a 0. Solve that equation. We've done this already. All it said was solve. That means find the 0. Find the root. Okay? Same thing. All right, so what do I want to do first? Yeah, you don't want to square this first, do you? That would be pretty ugly. Let's isolate this squared term. Remember how we isolated a radical? Same kind of thing. I don't want to FOIL this beast. Let's get rid of the 9 first. Okay? So 9 is 3x minus 1 squared. Do I want to square it now? You would? Jake wouldn't. What would you do, Jake? Sure, let's get rid of the 3. Because, hey, that's nice. 3 goes into 9. 3 divided by 3, she's gone. 3 goes into 9. Okay, 3 is x minus 1 squared. Now we have no choice. We got to take the square root of it. That's not that bad. Okay, whatever you do to one side, do to the other side. So the square root of 3 is x minus 1. Yeah. You're going to want to make it as nice as possible. If we FOILed it last time, we had no other choice. If you have a choice to simplify it down so you don't have to FOIL anything. Oh, you mean just this part?
Yeah.
Well, okay, so we know the square root of c squared c, right? Okay, the square root of c plus 1 squared is c plus 1. It's this whole thing squared. Okay? Because there's brackets there, that whole thing is squared.
I think she's asking why the concept, like why for the 1 year you did the FOIL. Because you had the 2 brackets side by side, you expanded them, right? So there's 2. Because like you could also do x minus 1 squared is x minus 1 bracket.
Oh.
You want that there. But outside of the root sign, don't even have the root.
Why didn't you FOIL this time? I get that
Yeah.
the root that it's just x minus
That's what we want to do. Like, that's nicer, yeah.
So we don't need to FOIL it?
No.
pattern. The last time we did have to do that, it was in general form. We wanted
There we
it
go.
in general form.
That's all I was on. That's all I was looking for.
That's all I was looking for.
Okay. We want, yeah, okay, all right. Are we good?
Why didn't you just tell me
I don't know.
that? They told me that.
Okay. Okay. Only I made a mistake here. Sort of. We got to do something else. Okay? How many x-intercepts are we expecting here if this thing's a parabola? Yeah. How many numbers is this thing going to give me? When I go square root of 16, what is that? Or, what's negative 4 times negative 4? It's also 16. There's 2 answers here. When you take the square root of something, you have to go plus or minus. Okay? That's going to give us our 2 roots. Otherwise, we only got one of them. Okay? So, x minus 1 is plus square root of 3 or minus square root of 3. I just got to do one more thing to get x. Add 1. Okay? Oop. Now, add 1 to both sides. Okay, that's what x is. Plus or minus the square root of root 3 plus 1. We probably want to write it like this. Okay, that just looks a little nicer. We usually want our number out front. Okay? That's what the two roots are. Could I double check that? What is approximately the square root of 3? Anyone know? So here's my two answers. My two answers are 1 plus root 3, 1 minus root 3. That's about 2.7. That's about 0.7. Let's have a look. Okay. Where's my function? 3 bracket x minus 1 bracket squared minus 9. Does that look like about 2.7 and, whoops, that should be minus. That's about 1.7, 1 minus 1.7 is minus 0.7. Look about right? Could we find that out exactly using zeros? Sure. Okay. Like I said, there's two roots here. If I don't remember this thing, then I'm only going to get one root. Okay? When you take the square root of something, there's two answers, right? Okay, so that's the harder one. Like I said, y-intercept, that's usually a bit easier. Okay? Does this thing have a y-intercept? Absolutely. Yeah, it crosses it right down here. Okay? What happens at the y-intercept? X is 0. Let x be 0. You can make that a y if you want. Okay, 0 minus 1 squared minus 9. So 3 times, what's 0 minus 1? Minus 1. What's minus 1 squared? 1. Minus 9, what's 3 minus 9? Minus 6. Does it look like about minus 6? Sure. Quickly, it's not accurate. Oh, there we go. Look at that. I was going to say, use your trace button. Sometimes you can get close. Sometimes, if you're lucky, it'll exactly show you the point. Is there another way I could find that point in there? Do I have a data table? What happens at the y-intercept? X is 0. There it is. The y-intercept is minus 6. Okay? Lots of ways. I just told you 4 ways to get the y-intercept here, right? Okay, is the last one? Yeah. Here's a graph. Does it look quadratic? Kind of look like a parabola? Okay, find the equation in standard form. What's standard form? Y is a x minus p squared plus q. Always, always, always. Okay, you remember that flow chart? This is the same as the first question, only we got a picture of it instead of it having it written down. What do I want to do first? Do I know the vertex? What's another word for maximum point? That's the vertex. It's right there. Substitute that in for P and Q. Y is a, x minus P again is negative, squared plus 2. Okay, let's just clean that up. X plus 1 squared plus 2. All I need is a, and I'm done. That's what they want. They want the equation, but I have to know what a is, right? Okay, because this could be anything. If a is fatter, it's going to look like that, right? If this thing's skinnier, it's going to look like that. I want this exact line, this one. So how do I find a? I need to know another point on this graph, and I can substitute it in. Do they give you another point on this graph? Yes, they do. Substitute that in. 1 is a minus 3 plus 1 squared plus 2. 1 is a, that's negative 2 squared, which is 4, plus 2. What would you do next, Jake? Divide by 4? Minus 1 is 4a. Now would you divide by 4? So would I. Okay, a is minus a quarter. Therefore, my equation is this guy, just with a substituted, x plus 1 squared plus 2. Is this guy going to be fatter or skinnier than the original graph? By a factor of 1/4. Oh, and it's reflected, of course, right? Yeah. Okay, so algebraically, the x-intercepts and y-intercepts. How do we get the x-intercept? What do we know with the x-intercept? Y is 0. Let it be 0. We got to solve this guy. Do I want to square this whole thing and FOIL it? Absolutely not. Let's get minus 2 over there. You got to write smaller. They don't give you much room. X plus 1 squared. Now what? This one's a little uglier than the last one. How do I get rid of that minus a quarter? I could divide both sides by negative a quarter. Do you like doing that? If I do what Dannon asks and multiply it by 4, what happens to that a quarter? What's 4 divided by 4? Only I'm just going to do one more thing. Why not get rid of the minus 2? Sure. Let's multiply it by negative 4. That will make this positive. Okay, so I'm going to have minus 8 here is x plus 1 squared.
It's a positive 8. Yeah.
Oh, yeah, you're right. Thank you. Okay. Even better. Now I don't have a minus. Okay, how do I get rid of that squared? Square root it, both sides, but what are we going to remember to do? Plus or negative. Okay, so plus or minus 8 is x plus 1. How do I get rid of the 1? Minus it to both sides. So my roots are minus 1 plus root 8 and minus 1 minus root 8. Okay, that's two answers, the plus or minus. Now that's exact answer. I actually, if this was radicals, that wouldn't be right. Why is that? Yeah, it's not simplified. That should say 2 root 2, but let's not worry about that. Okay? We've got bigger fish to fry today. Okay, that's an exact answer. It does say to the nearest hundredth. Do you think you could put that in your calculator and round that to hundredths? Okay, that's just a number, right? Okay, this is a root. That's a root. You could put that in. Find it to hundredths. Yes?
Will we have to simplify the other test?
Well, you're going to make me answer that right now?
Well, it would be nice if we would know now.
Okay, yes. Okay, but I mean, this is what we're learning, right? We're learning this stuff, finding the zeros. If that's a 2-mark question and you get that, I want to give you 2 out of 2. But on our final test, I mean, it doesn't make sense to have one question that says simplify root 8, and the next question is this as an exact answer. So if I'm going to take a deduction, it'd be like 1/4 of a point. Okay? So yeah, it should be. All right, quickly review. What's the domain of this thing? Have a look. We got a picture. Is there any x value that won't be on this graph? X is all real. How about the range? If only we knew the maximum point, we could find the range easily. Do I have the maximum point? Okay, how do I write the range? Range is y values in English, everything from this point down. How do I write that in math? Less than or equal to, what's that point? 2 is how high it gets, where y is the sum of all real, and axis of symmetry. Is that going to be our quiz tomorrow? You betcha. What happens? What is the axis of symmetry? Where is that? I almost drew it. It's that thing right there. That's where the left side equals the right side. That's the mirror. What's the equation of the axis of symmetry? X is, you see that number right there? That's what it is. Okay, so 1 to 6, but let's finish this up. I just want to say one little thing. Everything is compared to our, I can't draw on that, darn it. Okay, hang on. There it is, good. So we always want to compare to this graph. Okay? So quickly, how do I graph that thing? If x is 0, y is 0. If x is 1, what's 1 squared? 1. What's negative 1 squared? 1. If x is 2, what's 2 squared? 4. What's negative 2 squared? 4. One more. If x is 3, what's 3 squared? 9. Same thing over here. Okay, that's our basic parabola shape. Everything we want to compare to this. Okay? So if I say A is 2, okay, first of all, is that fatter or skinnier? What do I call that? Compression or expansion? Expansion. I know. Think of it this way. Every y value, okay, y is 2x squared. Why did I do that? A is 2. There. Every y value is twice what it used to be. Okay? It's skinnier. It's not 1 now. What's twice 1? It's 2. It's not 4. It's 8. Okay? Everything's twice what it used to be. That's what that guy looks like, roughly on the other side. Okay? It's expanded is the word. It's skinnier. If I go, A's a half. Okay? Well, once you know this one, then that one's got to be fatter. But think of this half. Every y value is half what it used to be. So it's not 1, it's a half. It's not 4, it's 2. It's not 9, it's 4.5. If you want to look at this thing and see what goes on, are you going to try to look at this point down here and see if that's a half or not? Because you can't tell. That might be a half, it might be 2/9, it might be 3/7, it might be a third. What you want to do is look for a point that's right on the crosshatch and compare it to the original. Okay? This one should have been 4, it's 2, so I know that's a half. Okay? So if I have something like this, 1/3, can you tell that that's a third there? You can't. Okay? What's 1/3 of 4? You can't tell what that is either. Right? But this point, it's not at 9. What's it going to be at? 1, 2, 3. That's the point you want to check. Right there. Okay? So you can't tell like looking in the fractions. You got to look at a whole point to determine. That is 1, 2, 3. That's the third point. So that should have been 9. How does 3 compared to 9? It's 1/3 as far from the x-axis. Okay, everything's from the x-axis. Okay? So can we take just a sec and for further learning, guys, I want you to mark other people's and write down there who's marking it. I should know because I got a list here, okay? Where is it? because this will be helpful for tomorrow. Okay, so can you groups? Shoney's group mark B, Lewis's, Tanner's, and Cassidy's. Can Lewis, Tanner, Cassidy mark Danon's, Aaron's, and Merrill's? So just go up, visually check it. Okay, because that's, your quiz is going to look a lot like that.